to आधीचा ऐकू आलं का? See, this is the question. A radioactive substance has a half-life of 140 days. The fraction of the substance that will remain after 2 years and 250 days is, as we have calculated lambda, which is a decay constant, 0.693 divided by 140 days, which is equal to 0.0495 per days. Now, the 2 years and 250 days, just add all days, 365 plus 365 plus 250, which is equal to 980 days. Now, we are going to calculate a decay constant. Obviously, this equation is similar as the first order rate equation. Lambda, which is equal to 2.303 divided by T log of A upon A minus X. Consider the initial concentration of a radioactive substance, which is equal to 1. Now, just put values in the decay constant equation. 0.00495, which is equal to 2.303 divided by 980 days. And log of 1 divided by the remaining fraction A minus X. Log of, just simplify this term, log of 1 minus log of A minus X. According to the mathematical law, log of x upon y, which is equal to log of x minus log of y. This log of 1 answer is 0. That's why we can neglect this term. The remaining fraction is 2.1063, which is equal to minus log of a minus x. Just take antilog of left side, antilog of minus 2.10 or 2.1063, which is equal to remaining fraction a minus x. The answer of a minus x comes 7.82 into 10 raised to minus 3. See, this is our answer, but we have to cross check this answer is exact or not, so that we are going back to our question. See, the first option is 1 by 7. Obviously, it you can calculate on your calculator. The answer does not matches to our answer. Then 127 divided by 128, which is nearly equal to 1. Obviously, this does not match. Then B option, obviously this fraction does not match. Take 128, answer comes 0.82 10 to minus 3. That's why our answer is correct. Now, the next question, which is based on the Schrödinger equation from quantum chemistry. See, here is the question. For a particle of mass c in a one-dimensional box of length 2L, energy level corresponds N is equal to 8 is given. The length of the box is given. One-dimensional box is there and length of the box is 2L. The energy N is equal to 8 and the options are as first option is 8 divided by 8 ml square. Second option is divided by 32 ml square. Third option is 8 divided by ml square. The fourth option is 1 is 2x square divided by ml square. So, to solve this problem, initially we have to know how much energy binds in the Schrödinger equation when the number of energy level is given. See, here is the answer. The Schrödinger equation useful for the one-dimensional box is E is equal to n square h square divided by 8ma square. Here, A is the length of, instead of A, we can put here 2 here, this equation. N is mass and N is equal to 8. Now we have the value of number of energy levels it. Don't put value of pH and equation. Put just values of A here and N here. So En is equal to at n square h square. Just put at instead of n. H square divided by 8m in a bracket 2l bracket square. The
आवाज येत नाहीये मिस.
hello, आवाज येतोय सगळ्यांना?
हो
Okay,
येतोय.
see now the question number 5. Question number 5 is based on the infrared spectroscopy. The question is, which of the following spectroscopic techniques will be useful to distinguish between M-SCN and M-NCS binding modes? See, here is the M means metal and SCN is the ligand. So, we have to find out the difference or these compounds which are going to study on the given instruments, the instrument differences, the MSCN and MNCS binding modes. See, here are the options. NMR spectroscopy. Is NMR spectroscopy distinguishes the MSCN and the MNCS? No, because NMR spectroscopy gives the idea about number of hydrogens, number of carbons, and the IR spectroscopy is the second option. Third one is the EPR, and fourth one is a mass spectroscopy. See, fourth option is the mass spectroscopy. Mass spectroscopy does not distinguish the MSCN and the MNCS binding modes because the mass spectroscopy measures the masses and masses of both are equal. So the next spectroscopy is the third option, EPR. Obviously, the EPR gives idea about the protons or the electrons. And the second option remains, which is the IR spectroscopy. And we have to find out the difference between MSCN and the MNCS. The IR spectroscopy is useful for this. In complex, the M-NCS group is linear or bent. When NCS ligand forms the bond with any metal, there is a formation of a complex, and this complex is a linear or bent. But when the MSCN forms a bond, or the SCN forms a bond with any metal, there is a structure formation, and this structure is always bent. That's why there is a separation of this, or there is a difference in these two structures which is observed on the IR spectroscopy. Because the IR stretching frequencies of NCS group and the SCN group are different. Our next question is the set of or the set among the following in which all numbers are magic numbers of nucleons. See, first magic number of nucleons means the nucleons contains number of protons and the neutrons, and magic number is related with this. Here are the options. First option given 20, 28, 50 and 126. Second option is 24, 28, 82 and 126. Again, third option is 20, 50, 80 and 184. Fourth option is 28, 50, 82 and 180. See, these are the options which are given for the magic number of nucleons. And guess the answer. Here, I have written answer A. You can cross check. The magic number is a number of nucleons, either protons or neutrons, separately, such that they are arranged into complete shells within the atomic nucleus. As a result of this, atomic nuclei with a magic number of protons or neutrons are much more stable than other nuclei. Means simply, the atomic number whose nucleons are equal to magic number, this is more stable than the other nuclei. The 7 most widely recognized magic numbers according to 2019, these are 2, 8, 20, 28, 50, 82 and 126. See, these terms or these numbers are included in option A, 20, 28, 50 and 126. That's why our option number 1 is correct. Now, the question number 7. Question number 7 is, conductivity is defined as the ability to carry. This question is very simple and you can guess the answer. Conductivity measurement is related with either voltage, resistance, current or all of the above. Here the answer is current because the conductance is measured. Conductance means what? The flow of electrons from one electrode to the another, and that can be measured on the machine. That's why exact answer is current. Obviously, in the definition of the cell constant, the resistance is included and the remaining terms are included, but the current is the exact answer. Because conductance is measured or the flow of electrons is measured and electron carries the current. And the question number 8 is here. If the ratio of composition of oxidized and reduced species in an electrochemical cell is given as concentration of oxidation divided by concentration of reducing species, which is equal to E square. The correct potential difference will be, this question is asked for 4 marks in the previous year NET exam. We have to know here the equation of Nernst, which is measured to calculate the E cell potential, and just put values of concentration of oxidation divided by concentration of the reductant species. Here I have written the answer. Nernst equation is E is equal to E standard potential minus RT upon NF. R means molar gas constant, T is a thermodynamic temperature, N means number of electrons transferred in the chemical reaction or participating in the reaction. F is a Faraday's constant, which is equal to 96500 coulombs, and into ln of oxidation, the species which undergoes oxidation divided by species which is undergoing the reduction. Here is the answer. E minus E0. Just put E standard at the left side. E minus E standard potential, which is equal to minus RT upon NF into ln of E square, because in the problem the value of ln of concentration of O divided by concentration of R is given here. The value is E square. Just put this value in equation 1. So ln of E square. When you can check the answer of ln of E, it will comes 1. That's why this value is just becomes 2. So left side is as it is, E minus E standard, which is equal to minus 2 RT divided by NF. ln of E square, this equation becomes 2 ln of E, and ln of E answer is 1. Therefore, only 2 remains here. The equation is E minus E standard, which is equal to minus 2 RT upon NF. See, the option is where either B, C, D or A. The option B is correct option, which is equal to E minus E standard is equal to minus 2 RT upon NF. Just we have to know the Nernst equation. Obviously, the values are given. Concentration of O divided by concentration of R, which is equal to E square. Just put this value there and find out final equation. This question is asked for 4 marks in the NAT exam. Such a simple question. Now, the question number 9 is here, which is asked in the SET exam. When completely protonated form of glycine is titrated with sodium hydroxide, which of the following represents the pH versus concentration of NaOH plot? And the chemical formula of glycine is given NH2CH2COOH. COOH. Here, just find out the dissociation of this glycine. Here, firstly, it dissociates as NH2CH2COO minus plus H plus. This NH2 absorbs this hydrogen and species becomes NH3 plus CH2COO minus. That means at one time there is a positive charge and negative charge present on this compound or the amino acid, and amino acid possesses a Zwitter ion, and this plus and minus charge at one time which is present on this glycine, there is a formation of a Zwitter ion. Means the compound shows the due to loss of hydrogen, obviously the acidic pH, and due to amine group there is a formation of a basic nature. See, first plot means we have to observe 2 endpoints. One is acidic and second one is a basic. And most of the MSc first year students have performed this experiment in our laboratory. The glycine is titrated with the NaOH, and the plot is prepared of pH and the ml of NaOH added. ml of NaOH added is on x-axis. See, the first diagram or the first option is here. In first option, the aqueous points are 3, first, second and 3. we have to observe only two equivalence points, pK1 and pK2. So first option is incorrect. See, second option is here. Obviously, plot is of pH versus ml of NaOH added. See, here is the two equivalence points are there. First one is acidic and second one is a basic. That means this answer is correct. We observe two equivalence points. One is at acidic, second one is at a greater pH than the 7. That's why just do addition of pK1 plus pK2 divided by 2. We can get isoelectric point, and the isoelectric point of the glycine, which is equal to 6.2. So the answer number 2 is correct. See, answer number C is there. Obviously, the NaOH is not titrated with the glycine, so third option is incorrect. Same, the fourth option is incorrect because we are adding NaOH externally, or the glycine is taken in the beaker and NaOH is titrated. The NaOH pH is more. So when we are going to add the ml of NaOH into the solution, obviously pH of the solution will increase but not decrease. That's why the option C and D are totally incorrect. Only option B is correct. Option 1 is incorrect because the three equivalence points are observed in this diagram. See, this is the diagram of the titration of glycine versus NaOH. Here on the y-axis, the pH is written. On the x-axis, there is a ml of NaOH added. And the first equivalence point of glycine is observed at 2.3 and second equivalence point is observed at 9.6. Two equivalence points are observed. That means the glycine is an amino acid. It forms its bitter ion. There is a positive charge and negative charge at one time present. So this compound shows two equivalence points, and just find out isoelectric points. So this is all about the question number 9. Now the question number 10. Obviously this question number 10 is very simple, which is based on the kinetics. The half-life of a zero order reaction. The reaction is given, A gives product. It's given by, we have to find out the half-life equation. See, just answer number 1 is the right. T half is equal to concentration of A0 divided by 2K. Obviously, this question is asked for 2 marks for NET exam. Remaining options are incorrect. So, see, here I have written the table which includes all the concepts which are related to the kinetics or the first order, second order, or the nth order. Just keep in mind the nth order column, and you can find out the all parameters like rate law, integrated rate law, unit of rate constants, linear plot of the rates like a zero order, first order, second order, and the half-life of all equations by just keeping in mind all these terms which are included in the nth order equation. See, half-life of the zero order reaction is given here. T half is equal to concentration of A0 divided by 2K. As you know that the equation of the zero order is X is equal to KT. Instead of X, you can put concentration of A. A is equal to KT. And the concentration of A becomes 50% at the half-life, so that the concentration becomes half, A by 2. And the equation is as written here. T half is equal to concentration of A0 divided by 2K. Now the question number 11 is, a process is carried out at a constant volume and at a constant entropy. It will be spontaneous safe. See, the spontaneity criteria are given below. in the option. Delta G is less than 0, delta H is less than 0, delta U is less than 0, and delta A is less than 0. See what's given in the problem? Constant volume is there and entropy is constant, and we have to find out the spontaneity relation. So, see, I have written here the answer. As we know, the equation of the change in entropy is greater than Q by T. This is the Clausius equation, and this is included in the second law of thermodynamics. And this equation is also written as T delta S is greater than Q, and the equation of Q, which is equal to delta U plus P delta V. This equation is taken from first law of thermodynamics. See, from equation 1 and from equation 2, T delta S is greater than delta U plus P delta V. Just put equation 2 in equation 1. T delta S is greater than delta U plus P delta V. Or this equation is written as delta U plus P delta V. The pressure is written as a P external. Delta U plus P delta V minus T delta S, which is less than 0. When volume and entropy kept constant, that means obviously delta V is equal to 0 and delta S is equal to 0. When these two terms are 0, delta V is equal to 0 and delta S is equal to 0, obviously equation becomes the delta U is less than 0. Means just put delta U plus P external delta V minus T delta S, which is less than 0. The P external delta V equation becomes 0 because delta V is equal to 0. We kept volume constant. Second term becomes 0. Then third term is minus T delta S. Obviously entropy remains constant. That's why the term is equal to 0. So our spontaneity equation is delta U at a constant volume and constant entropy, which is less than 0. So our answer C is correct. Now the question number 12 is here, which is based on Debye-Hückel limiting law. Question is, for an aqueous solution at a 25 degree Celsius, the Debye-Hückel limiting law is given by, the options are written here, log of gamma plus minus, which is equal to 0.509 mod of Z plus into Z minus into square root of mu. You people or the MS1 students have already used this equation for the calculation of a solubility product of a sparingly soluble salts. Guess the answer. The answers are written here. Log of gamma plus minus is equal to 0.509 into mod of Z plus Z minus into square into mu just, which is written in option B. C option is log of gamma plus minus, which is equal to minus 0.509 mod of Z plus into Z minus into square root of mu. And last option is log of gamma plus minus is equal to minus 0.509 mod of Z plus into Z minus mu square. See, the answer of this equation is written here. The Debye-Hückel limiting law is useful for the determination of the activity coefficient of an ion in a dilute solution and whose ionic strength is known. The equation of Debye-Hückel limiting law is ln of gamma plus minus is equal to minus A into Z square into square root of mu. See, the value of A is 0.509 mole raised to minus half kg raised to half if base minus 10 logarithm is used. So the above equation takes the form log of gamma plus minus is equal to minus, just put this value 0.509 instead of A, and mod of Z plus Z minus. Here Z plus and Z minus are the charges present on the positive and the negative species. Suppose take KCl. KCl, when this is a dilute solution, there is a dissociation of this species K plus and Cl minus. K plus means K species contains positive charge, means you can write here +1. Then Cl minus, it contains -1 charge, just put here +1 and -1. And into square root of mu. Mu is a reduced mass which is calculated by using equation m1 into m2 divided by m1 plus m2. By using this, you can find out log of activity coefficient, log of gamma plus minus, and see the answer is answer number 3 is the correct option. Log of gamma plus minus is equal to -0.509 mod of z plus z minus into square root of mu. Now the question which is based on the polymer chemistry. Obviously this question is asked for 4 marks in the NET exam. The contour and the root mean square length which is given in nanometer, or we have to calculate this answer in nanometer, of a polymer chain modeled as a random coil with N is equal to 1000 and L is equal to 150 picometers are closest to. See, in problem we have to calculate the contour and the root mean square length of a polymer, and the length can be calculated in nanometer. See, the polymer is in the form of a random coil, and the number of polymer or the number is given which is equal to 1000, and the length of the polymer is given 150 picometer. Now we have to convert this picometer into the nanometer initially. So 150 into 10 raised to minus 3, it becomes the nanometer. N remains as it is 1000. So now we are going to solve this problem, and then we can check which answer is the correct answer. See how to find out the contour and the root mean square length of a polymer. See here, the equation of the root mean square length is given, which is equal to square root of N into L. We know the value of N and the L. Just put values here. Square root of 1000. 1000 is the value of N into L value is 150. But this answer is given in picometer, and in problem they asked you to solve the problem in nanometer, or to find out root mean square length in the nanometer. So just multiply it with 10 raised to minus 3. The equation becomes nanometer. And by calculating these values on calculator, the answer comes 4.74 nanometer. This is the root mean square length of a polymer which is in the form of a coil. And we have to calculate the contour for this polymer. The contour is just calculating by multiplying these terms given in the problem, N into L. This number of the polymer given, and the L means length of the coiled polymer. Here N is equal to 1000 into 150. Sorry, here 10 raised to minus 3 is written by mistake. So length of the polymer is, we have to calculate in the nanometer. So just take this value 10 raised to minus 3. 1000 into 150 into 10 raised to minus 3. This 10 raised to minus 3 cancels 1000. So these terms get cancelled, and only 150 remains. So the polymer contour is 150. So find out the answer of these two. Root mean square length which is calculated by us is 4.74 nanometer, and the contour of polymer which is coiled, which is equal to N into L. L is taken here in the nanometer instead of picometer. If you can take only picometer, then convert your final answer into nanometer. So 1000 into 150 into 10 raised to minus 3, answer comes 150. So check the option 150 and 4.74. The option number 4 is the correct option because in all the options these values are not present. So 150 and 4.74 is the correct answer for this. Now, the question number 14, the translational partition function for argon confined to a volume of 1 liter at 300 Kelvin having thermal wavelength of 1.60 into 10 raised to minus 11 meter is closest to. See, for this or to solve this problem, we have to know a better knowledge of a molecular statistical analysis. In molecular statistical analysis, we can study the uh, thermodynamics on the molecular level, on the micro level, where the transitions are studied. As we know, the energy levels are the electronic energy levels, vibrational energy levels, rotational energy levels, and the translational energy levels. And we have to distribute the given number of particles or molecules in the available energy levels. And for that, there is a partition function. Partition is just distribution of the molecules, ions or electrons or atoms in the available energy levels or in the given system. So there are various types of partition functions, as a translational partition function, rotational partition function, vibrational partition function, and the electronic partition function. Here the value for argon are given. The volume is given 1 liter, temperature is given 300 Kelvin, and the thermal wavelength lambda is given 1.60 into 10 raised to minus 11 meter. Now the options are given here, but I will tell you how to solve this problem first. The translational partition function is calculated by using this equation QT. Q represents the partition and T represents the translational motion, which is equal to V upon lambda cube. V means volume and this lambda is the thermal wavelength. Here volume is given in the problem is 1 liter and the thermal wavelength is given 1.60 into 10 raised to minus 11 meter. Just put values and you know that the 1 liter, which is equal to obviously 1000 centimeter cube. Just put value here and you have to calculate the thermal wavelength in terms of the centimeter. Here the value is given meter, just convert it into centimeter. So the value becomes 1.60 into 10 raised to minus 9 centimeter and keep this cube as it is here. After calculating this, the equation answer is Qt is equal to 2.44 into 10 raised to 29. This is a simple problem, but the conversion is important. See, where is the answer? Option number 2 is the correct answer, 2.44 into 10 raised to 29. Same way, the problems on the partition function or the vibrational partition function, electronic partition function, and the vibrational rotational partition function can be asked on the previous year papers. You can solve these problems. Here is the question number 15. The IR spectroscopy, which frequency range is known as the fingerprint region. This is a theoretical question. IR spectroscopy, which frequency range is known as the fingerprint region. See here, first is written 400 to 1400 centimeter. Second one is 1400 to 900 per centimeter. Option C is 900 to 600 per centimeter. And last option is 600 to 250 per centimeter. Guess what is the answer? Here I have written the answer. Answer number B is the correct answer. The UV visible spectrophotometer, which is in our lab, which works from 200 to 1100 nanometer range, and here the frequency values are given. The nanometer values are of a wavelength. See carefully, these values are of frequency, not of a wavelength. So just check. The answer is 900 to 1400 per centimeter. These values are of frequency, and this is a fingerprint region of an infrared spectrum, and each molecule or each compound has a characteristic property, the fingerprint. Question number 16 is here, which is obviously asked for 4 marks previously. The third and fourth lines in the rotational Raman spectrum of a carbon monoxide are separated by 8 per centimeter. The carbon monoxide bond length is given by. Just here, the knowledge of the Raman spectroscopy in detail is required, as in each spectroscopy, the transition occurs differently. As a macro spectroscopy, it obeys delta J is equal to plus minus 1 rule. The Raman spectroscopy obeys delta J is equal to 0 or plus minus 2 selection rule. Then vibrational spectroscopy obviously obeys the different selection rules of harmonic oscillator and the unharmonic oscillator, where the transitions occur according to selection rule delta V is equal to plus minus 1 or delta V is equal to plus minus 1, plus minus 2, plus minus 3 and so on. Each and every spectroscopy see, the n is equal to 3 and n is equal to 4. The transition occurs from, or simply don't say transition, the energy level gap is given here, which is equal to 8 per centimeter, and we have to find out initially value of the rotational constant B for the carbon monoxide, and then we have to calculate the bond length. The options are given as here. Option number 1, which is equal to square root of h upon 16 pi square mu c. Second option is 3h divided by 32 pi square mu c. Third option is square root of h upon 32 pi square mu c. And last option is square root of 5h divided by 32 pi square mu c. These are the 4 options which are given for the bond length of a carbon monoxide. Now see how to calculate the bond length. See, the Raman spectroscopy obeys the selection rule delta J is equal to plus minus 2. This is, I have written for your information here. The transition occurs from 0 to 1, 2 to 4 or 1 to 3. Means there is a difference of plus minus 2 obviously. Means 3 minus 1 which is equal to 2, 4 minus 2 which is equal to 2, and the 2 minus 0 obviously 2. Means each and every transition, either excitation or de-excitation. When there is excitation, the selection rule is delta J is equal to plus 2. And when there is a de-excitation, selection rule is delta J is equal to minus 2. Such a type of transitions occurs in the Raman spectroscopy. And see here, Stokes lines and the anti-Stokes lines are observed in the Raman spectroscopy, and this thick bond shows the Q band, and at the left side there is a transition, and the difference between this, or the energy gap between these transitions, is the 6B. Then from this, at the left side or at the right side, all the energy level contains the gap of 4B. Here I have written 4b. Only the Q band and the first energy level contains gap of a 6b, keep in mind. And the remaining all the excessive lines contains the energy gap which is equal to 4b. This is the hint for this problem of a Raman spectroscopy. So in the problem, the value of 8 per centimeter given, which is of a 4b, means 4b is equal to 8 per centimeter. So b is equal to 2 per centimeter. See, when instead of Raman spectroscopy, there is a word written microspectroscopy. At that time, you have to take, instead of 4b, there is a 2b. Whatever the value given in the problem, either 8 centimeter, 10 centimeter, and so on, it will be half for the microspectroscopy, or b is equal to 5 per centimeter. But for Raman spectroscopy, the energy gap between two energy levels, 1 to 2, 2 to 3, 3 to 4, or so on, the energy gap is 4b. So b is equal to 2 per centimeter, and we know the equation of a moment of inertia. I is equal to mu r square. Here mu is the reduced mass, r is the radius or the bond length, and I is the moment of inertia. Now we have to find out the bond length of a carbon monoxide. Means we have to find out just R of a carbon monoxide. So just rearrange equation of the moment of inertia as R square, which is equal to I divided by mu. Now the equation becomes R is equal to square root of I divided by mu. And we know the equation of I is equal to h upon 8 pi square bc. Instead of b, just rearrange equation, you can rewrite this equation as b is equal to h upon 8 pi square ic. Means these two terms are vice versa. You can either find out I or b. Here b is given in the problem, so you can easily calculate value of the I. So the moment of inertia is equal to h upon 8 pi square bc. Now just put value of I in the equation of radius. Radius is equal to, or radius, instead of radius, you can call it as a bond length of a carbon monoxide here. So bond length of carbon monoxide is equal to square root of h upon 8 pi square bc into mu. This term is kept as it is here into, and mu remains as it is here. So the value of B is calculated above is 2. Just put value here. So bond length equation comes square root of h upon 8 into 2, which is equal to 16. So square root of h upon 16 pi square mu c. This is the answer. And here are the options. So option number 1 is the correct answer. Square root of h divided by 16 pi square mu c. This is the bond length of carbon monoxide in the rotational Raman spectrum. See, the question number 17 is written here. This is based on the conductometry. The conductivities of a water and a saturated solution of a sparingly soluble salt AB2 are 7 and 21 microseconds per meter. Means conductivities of water and saturated solution are given, which are 7 and the 21 microseconds per, microseconds, no, the unit of conductance is here, microsiemen, instead of second it is a siemen. Siemen is a SI unit of conductivity. So microsiemen into per meter, this is a unit. Given are the values of the equivalent conductance of two species, the lambda of A2 plus, which is equal to 12.72 millisiemen meter square per mole, and the equivalent conductance of second species B minus is given 7.64 millisiemen meter square per mole. So we have two conductance, one is of water, second one is of a saturated solution, and the next given is the equivalent conductance of a positive ion which is dissociated and the equivalent conductance of a negative ion which is dissociated. Now we have all four terms and the compound is given AB2 and we have to find out solubility of AB2 in mole per meter cube. So options are given 5 into 10 raised to minus 4, second one is 5 into 10 raised to minus 3, third one is 5 into 10 raised to minus 5, and fourth one is the 5 into 10 raised to minus 6. Means from this we can say the first term is 5, but remaining parameters we don't know. So now we will check how to find out the solubility from the conductivity and the equivalent conductance. So here is the answer. See, AB2 is the molecule which is given in the problem. AB2 dissociates as A2 plus 2B minus. And given values are written here. Equivalent conductance of A2 plus which is equal to 12.72 millisiemen meter square per mole. We have to find out or we have to convert these values in the siemen. This is a milli, so just multiply by 10 raised to minus 3. So equivalent conductance of A2 plus is 12.72 into 10 raised to minus 3 siemen meter square per mole. Same way you can convert the equivalent conductance of a negative species B minus and it comes 7.64 into 10 raised to minus 3 siemen meter square per mole. Now they have given two values of conductance. One is of water and second one is of a saturated solution of a sparingly soluble salt. So K water is equal to written 7 microsiemen per meter and the K solution is equal to 21 microsiemen per meter. So just convert again all the values are in the siemen. So just convert these values in the siemen and macro is equal to 10 raised to minus 6. Just multiply 7 and 21 by 10 raised to minus 6. Now these are the given values and now the solution. Solution contains what? Water plus solid. And solid, how to find out solid amount? Which is equal to obviously solution minus water content. So instead of K solid, we can put K solution minus K water in the equation of a solubility. See, I have written here equation of a solubility. Solubility is equal to K solution minus K water. Before this equation, there is a one equation which is original equation. An equation of solubility is solubility equal to K solid divided by equivalent conductance of positive ion plus equivalent conductance of a negative ion. But we have directly written instead of K solid, K solution minus K water divided by equivalent conductance of a positive species plus the negative species dissociates as a 2B minus. That's why here written 2 into equivalent conductance of B minus. Just put all the values in the equation. K solution is 21 into 10 raised to minus 6. K water is 7 into 10 raised to minus 6. And units are important. So just put units here. Divided by equivalent conductance of A2 plus species 12.72 into 10 raised to minus 3 and the value of the equivalent conductance of a negative species is written here 7.64 into 10 raised to minus 3. Just multiply here by 2. Here 2 is remain and units are siemen meter square per mole. Our answer comes 5 into 10 raised to minus 4. So answer number 1 is the correct answer for the solubility of a species AB2. So to find out the solubility of any species, either AB2, BA2 or anything, you have to find out initially the dissociation equation of this molecule and just find out the equation of a solubility. Solubility is equal to K solid divided by the dissociation values are given here, or the required conductance of a dissociated species are given. Just put values and find out the equation of a solubility. The next and very important question is here, which is based on the kinetics or the ozonolysis reaction. The decomposition mechanism of ozone is O3, which gives O2 plus oxygen, and the forward rate is K1 and the reverse rate is K minus 1. Next reaction is given here, O3 plus this intermediate form is taken here, O3 plus oxygen, which gives 2 O2, and the rate of this reaction is a K2. Here we have to form the O2 from O3. But see here, O3, which gives initially O2 plus oxygen, then the ozone from the system reacts with the intermediate which is formed is oxygen, and then there is a formation of a 2O2. Now, suppose the K minus 1 into concentration of O2 is very less than K2 into concentration of O3. Means ozone concentration is very much higher than the concentration of a O2 which is formed. Then the order of the reaction with respect to ozone is. So by saying equation, we cannot say the equation is first order or second order. So just follow the process as here. We have to solve a long derivation for this, and you can find out the rates of a oxygen, ozone and O2 separately. So first I am going to write dO by dt. Here is a dO by dt, which is equal to K1 into concentration of O3 minus K minus 1 into concentration of O2 into concentration of O minus K2 into concentration of O3 into concentration of O. This equation is prepared from this rate. See, firstly I have written the dO by dt, means the rate of formation of this oxygen with respect to changing time. This oxygen is formed from ozone. So the rate of formation is written in the plus sign and rate of decomposition is written in the minus sign. And this O2 is initially prepared, so I have written the first term here, K1 into concentration of O3. Means oxygen is formed with rate K1 from O3. This is first term of this equation, minus K minus 1 concentration of O2 into concentration of O. This oxygen is included here, or O2 plus O. There is a backward reaction to form O3, means this oxygen goes to decay or decompose to form again ozone. That's why the oxygen is involved in the 3 steps. So I have written equation number 1 is here. And you know that the steady state approximation is applied to find out the concentration of a product. But before that, the steady state approximation is applied only for the intermediate species, and we have to say the intermediate species concentration is nearly equal to 0 or negligible as compared to the product. So here is we can apply the steady state approximation to the equation number 1. That's why this left term is equal to 0. Just rearrange the equation as K1 into concentration of O3 minus K minus 1 concentration of O. We just put at left side is equal to 0. Take minus sign, minus terms to the right side, all terms becomes positive, rearrange the equation and find out the concentration of oxygen. Now we have the concentration of oxygen, but aim is to find out the concentration of a product. And the product is O2. and rate of change of concentration of O2 with respect to change in temperature is given by equation K2 into concentration of O3 into concentration of O. Now we have the equation number 2 and equation number 3. Just put value of equation 2, which is of oxygen, in the equation number 3, and just equation of this is dO2 by dt is equal to K2 into concentration of O3 into K1 into concentration of O3 divided by K minus 1 into concentration of O2 plus K2 into concentration of O3. See, O2 is intermediate here in the first step. O3 gives O2 plus oxygen, and in last equation O3 plus O again gives 2O2. But this intermediate forms, which is O2, is less as compared to the initial O3. Here written K minus 1 into concentration of O2 is very, very less than K2 into concentration of O3. This condition is given in the problem. That's why we can neglect the term of K minus 1 into concentration of O2. So the final equation just remains dO2 by dt is equal to K1 into concentration of O3. And here is no power on the concentration of O3. There is no power means only 1 is there. So we can write K1 into concentration of O3. And the order means what? It is the sum of raised to power of concentrations. And here is the only one concentration, which is O3. So just the order of the reaction of ozenolysis given in this problem, which is equal to 1. So option number 2 is the correct answer. And this problem is asked for 4 marks in the NEET exam. See, again, such type of problems you will get in the previous year papers. Same problem is asked for here. The problem is asked for helium plus. Same problem is asked for lithium plus, and so on. The problem is the ionization energy of a hydrogen atom in its ground state is approximately 13.6 electron volt. The energy of ionization energy of hydrogen atom is given 13.6 electron volt, and the potential energy of the helium plus we have to calculate, and it is in the ground state. Options are given here: minus 54.4 electron volt. Second option is minus 27.2 electron volt. Third option is minus 13.6 electron volt. And the fourth option is minus 108.8 electron volt. These are the options. Now we are going to learn how to find out the potential energy of a He plus or lithium plus or He2 plus and so on from the by knowing only the ionization energy of a hydrogen. See, here is the answer. We have given the ionization energy of a hydrogen atom. And now we have to calculate the potential energy of a He plus. See, here is the equation to calculate the potential energy. Energy is equal to 13.6 into Z raised to 2 divided by N raised to 2. And this energy is calculated in the electron volt. This equation is just as 13.6 Z square divided by N square. For hydrogen atom, Z is 1 and the N is obviously 1. But for helium plus nuclei, Z is equal to 2 and the number of electrons is equal to 1. Because 1 electron is already lost. Species is He plus. Putting that value Z is equal to 2 and N is equal to 1 in the equation of E. E is equal to 13.6, Z is equal to 2, therefore 2 square divided by 1 square. The answer comes 54.4 electron volt. But see here, the energy is equal to minus 13.6 Z square divided by N square. This is the correct equation.
Here, the minus sign is not written. So our answer comes minus 54.4 electron volt. Equation is, I am repeating again, energy is equal to minus 13.6 Z square divided by N square. After putting Z is equal to 2 and N is equal to 1, we will get the value of potential energy of a helium plus nuclei, which is equal to minus 54.4 electron volt. So check the answer. Here is the first option, which is our answer, minus 54.4 electron volt. This is a potential energy of a He plus nuclei in the ground state. See, question number 20. Again, this is a very important question in the SAT exam. Here, the ionic strength of a solution containing 0.008 molar AlCl3 and 0.005 molar KCl is. Means, you know the equation of ionic strength, I is equal to half into summation of Ci Zi square. C means concentration and Z means the charge. But when one molecule, the finding ionic strength is easy, and when two molecules, the ionic strength is calculated as, here I have written the equation of ionic strength, I is equal to half into summation of Ci Zi square. C means concentration, Z means charge. And for our species AlCl3 and KCl, we have to find out initially how this species can dissociate. AlCl3 dissociates as Al3 plus 3 minus, and KCl dissociates as K plus Cl minus. And the concentration of these two species are given. Concentration of AlCl3 is given in the problem is 0.008 molar, and the concentration of the KCl is given 0.005 molar. Okay, see, just put the values of the concentration and the values of the charges. The first term AlCl3 dissociates as Al3 plus 3 Cl minus. So first term is for AlCl3. Half is outside the bracket, and in first bracket, just do calculation of the Ci Zi square. Concentration of obviously Al3 plus ion is 0.008 into ion is 1 into charge is plus 3, therefore 3 square. This is for Al3 plus. Second term plus 0.008 into minus 1 square into 3, because Cl minus contains 1 charge and charge raised to 2. And how many Cl minus ions are there? 3. That's why I have written here 3. This is for AlCl3. And ionic strength is a summation. So just do addition of second terms. So in second bracket, concentration of KCl is given 0.005. So K plus ion concentration is obviously 0.005. The K is 1 and charge is 1, plus obviously Cl minus concentration is 0.005 and the charge is minus 1, do it square, and the Cl is 1. After calculating all this, the value of ionic strength comes 0.053, and the our answer is, answer number 2 is the correct answer, 0.053 molar. Okay, and this is the most important question for the NET or SAT view. See, such a type of problems were oftenly asked in the NET exam and the SAT exam, and this problem is asked for the 4 marks. Here, I am not explaining this problem in detail, but the hint of this problem is very important, and you can get easily 4 marks in the NET exam on the basis of this hint. See, the problem is given here. the character table for the D3 point group is as the point group character table is given here. E, 2C3, 3C, and for this point group, the correct statement among the following is. First option is, it is possible to have a totally symmetric normal mode of vibration which is IR active. Means the molecule is symmetric and the normal mode of vibration is IR active. This is first option. Second option is all IR active normal modes are necessarily Raman active. This is not the correct statement. Third one is all Raman active normal modes are necessarily IR active. Again, this is not the condition. And last option is, it is possible to have a pair of IR active normal modes that are degenerate. See, the various types of point groups are given in the previous year problems, but here is the D3 point group, and D3 point group example is the ethene. For solving this type of problem is, for IR activity, the irreducible representation that must contain X, Y, and Z. The irreducible representation which contains either X, either Y, or either Z, or all of them, these are IR active modes. And when the irreducible representation contains XY, YZ, XZ, or Z square and X square minus Y square, any one of them is present, the mode is a Raman active mode. See, in this problem, see A2 contains Z, then E contains X and Y. In the problem, anywhere X, Y, and Z is present, these modes are the IR active. Means A2 and E modes are IR active. Then see, A1 and remaining all the terms A2, E contains the XZ, YZ, XY, Z square, X square plus Y square, and X square minus Y square. These three terms or these three modes are Raman active, but first mode is IR inactive. So we can't say all modes are Raman active and these modes are also IR active. So this is a hint. So here is a possibility to have a pair of IR active normal modes that are degenerate modes. This is the final answer. Means just they ask you to find out the given molecule or the given point group is active to IR or active to Raman. Just keep in mind XYZ, the irreducible representation contains XYZ, the modes are IR active, and XY, YZ, XZ, Z square, and X square minus Y square or X square plus Y square, where present this mode is Raman active. Okay, and the next question is, the symmetric rotor among the following is. The examples are given here: CH4, CH3Cl, CH2, CHCl, and the CCl4. Such a type of questions are asked many times for 2 marks, and this is an important point. See, symmetric rotor, spherical top, symmetric top, asymmetric top, or the linear molecules. These are the types of the rotors. See, here I have written the options as a CH4, which is an example of a spherical top, where the moment of inertia IA, IB, and IC all are equal. And such a type of molecules are microwave inactive, where then the second option is CH3Cl, This is an example of a symmetric top, and symmetric top contains IB is equal to IC, which is not equal to IA. This is the condition for symmetric top molecules. But there are two types of structures we are obtained. As the first one is a prolet structure and second one is an oblate structure. Prolet means what? The egg-like structure, and the oblate is a circular or the rounded shape. Here, the prolet structure obeys IB is equal to IC, which is greater than IA. And example is CH3Cl, CH3F. And the oblate structure is of a BCl3. Next, C option is here, CH2CHCl, which is a asymmetric top. And another example of this is water molecule. And for asymmetric top molecules, IA is not equal to IB, and this is not equal to IC. And last option is a CCl4. Again, this is a spherical top molecule where each and every moment inertia is different. IA is not, this is an example of spherical top, and all the moment of inertias are equal. IA is equal to IB, which is equal to IC. CH4 and CCl4 are microinactive. Then there is only one example, CH3Cl. This is the example of a symmetric rotor or symmetric top, which is given here, CH3Cl. So option number B is the correct answer. Now, if anyone want to ask some queries, you can ask.
If you have any question, please write in chat box or you can directly ask to madam. Any questions?
Okay.
Question 6.
Okay, question 6 is a theoretical question. The set among the following in which all numbers are magic numbers of a nucleons. Here, the options are given. Out of them, first option is correct option. Here, the nucleon contains the positive ion and the negative ion. We can say that the proton and the neutrons. And the magic number is a number of nucleons such that they are arranged into a complete shells within the atomic nucleus. And the nucleus, which contains magic number of protons or neutrons, this nuclei is more stable than the others. And the magic numbers, according to a list of 2019, these numbers are 2, 8, 20, 28, 50, 82, and 126.
Okay, any more questions? I think there are no questions. So from the madam's presentation, what I learned is there is no shortcut to success. Only key for the success is hard work, because madam's presentation includes so many questions and every question have a very well explained answer. So I thank you madam on behalf of Department of Chemistry and PC College Baramati. Also I thank you all for joining us live for this session. So thank you very much. If you have any doubt, you can ask in our Telegram group. Thank you very much.
Thank you, sir, and thanks college for giving me opportunity to take this lecture and interact with you people. Thank you, you also.
Thank you, madam.